Today's lesson is a continuation of section 7.6, solving systems of linear inequalities. In the previous lesson, we talked about how to solve a system of linear inequalities with, if I have two or three of them, I can graph them just like we learned at the end of chapter 6. And remember, with an inequality, we're actually finding an entire set of solutions, not just one solution, but there's often a set of them. And then if I'm graphing a system of these, well, it's kind of like as I talk about a process of elimination. We're finding all the answers where the area where all the answers could be and kind of eliminating other areas, and then we'll be down to just our last area with everything shaded in, where every inequality has some area of it shaded in, and that'll be our answer. So I'll go through one example here, and then I'll talk about going backwards through some systems. What if they give us a graph and we need to make the inequalities? But first I'll go through one more example here of us graphing a system of inequalities and finding all the answers. So this one right here, and this system has three different inequalities in it. I'm going to graph the first one here in blue. 5x plus 7y is greater than negative 35. So first, again, it's set up nice to find the intercepts. It's set up in standard form, so intercepts is a good way to graph this one. If I put in 0 for x, it would cross off that x term or really cancel it out. And dividing negative 35 by 7 would give me negative 5 for my y-intercept. And then if I put in 0 for y, my x-intercept would be negative 7. So I can find my two intercepts, my x and y-intercept, graph those. These will be 2 points that I can use to graph my inequality. 0, negative 5, and negative 7. 1, 2, 3, 4, 5, 6, 7, 0. There's my inequality. Again, looking at the inequality itself, since it's greater than and not greater than or equal to, I know this will be a dashed line. So this will be some kind of dashed line, again, telling me that the answers are not part of the line. They're just on one side or the other of the line. It's more of just a boundary. And if I want to find out which side the answers are on, I can plug in a point like 0, 0 and see if this is a solution or not. So if I put in 0 for x and 0 for y, I'm going to get 0 on this side. Is 0 greater than negative 35? Well, yes, it is. So that means that all the solutions must be above the line, because that's where 0, 0, the origin is. So I'd shade in all that section for the blue inequality. Going on to the next one, we'll make this one in green. Y is less than or equal to 2x plus negative 6. Since it's in slope-intercept form, the easiest way to do this one is graph using slope-intercept form. So my slope is 2, my y-intercept is negative 6. I go down 6 on the y-axis, put a point, and I'll go up 2 over 1, up 2 over 1, up 2 over 1 to find more points. And I'll make a bunch so that I can make a nice line. In this case, since it's less than or equal to, this tells me it's going to be a solid line, and that any point that is on this line is part of the solutions for this inequality, and potentially could be for the system as well. And then also, again, when it's in slope-intercept form, when I have it in this form where y is by itself, then I can just look at the inequality and also say that, well, it's less than, so all the solutions are going to be less than a line or beneath the line, I could say. So here's now where I've got shaded in for green. So these are all potential solutions. So far, where the blue and green overlap, those are my solutions for the system. But I do have one more inequality here. Y is greater than negative 2. And remember, as I talked about in the previous lesson, if you watched that one already, I talked about thinking of this if it helps. This is kind of a special case, or one where there's no x involved, so sometimes it can throw people off a little bit. But if it helps, think of this instead. Y equals negative 2. So where is that? Well, along the y-axis, that means I would go down 2. And then it'll be a horizontal line everywhere where y is negative 2. So it's just down 2 from the x-axis. So right here, and then it'll be just this horizontal line. And in this case, if I look at it here quickly too, I can see it's going to be a solid line because it's greater than or equal to. So there's my line where y is equal to 2. And if I want y is greater than or equal to 2, well, now I'm just going to shade all the points that are above. So starting over here, and I would shade all the way over here. These are all solutions to the system. But what I'm looking for solutions to the system, sorry, the red is just all solutions for that inequality. But if I'm looking for the solutions to the system, we're above the red line, below the green line, and above the blue line. So over here in this little area is where I'm going to find all my solutions, below the green and above the red. And above the blue. So I think this area right here looks like the area of my overlap. So There's all my potential solutions, or all my solutions for this system, I should say. And again, there are many solutions, an infinite amount. So I could pick any point along here. Let's say I pick the point, 10, 10, 8. That point would be right here, 10, 8, okay? And I could pick any points in that black, but that solution should work in every single inequality because it's a solution to this system. So again, just kind of showing that as well. So 5 times 10 would be 50, plus 7 times 8, which would be 56. Yeah, I think that's going to be greater than or equal to negative 35. So it's going to check out for that one. Plug it into the second one. 10 times 2 gives me 20, plus negative 6. That's going to be 14, which is, well, that 14, or I should say 8 is going to be plugged in here over for y. And I know I'm kind of writing over my other stuff, but just to kind of quickly show that it's going to work, 8 is going to be less than or equal to 14, so it's going to work on that one. And if I just put y in for this one, the y coordinate, 8, yep, is greater than or equal to negative 2. So I kind of explained that in the first lesson as well, but just kind of showing you quickly, yes, since this point works in every inequality, it must be a solution to the system. Well, I'm also going to show us that sometimes we have to go backwards. Sometimes they give us the graph for the system, and we have to figure out what all the inequalities are. And again, we are definitely capable of doing this. We're going to find like maybe a problem like this where they've shaded in just the final region, just not with all the shading that we've done in the past, but just the region that's overlapped by all the shading. So in this case, it's this green area here. I'm trying to make a system of inequalities that would give me that as the solutions. Well, to start off, I'm going to look at, I've kind of given us a little bit of help here so we don't have to find it, but I've given us some information maybe about this line, and that's something that you could find though for a particular line. If you have to find out what the slope and y-intercept of it is, then you can definitely look and find those things from the line just by finding the y-axis right here and seeing where the line intersects it, or also what the slope of it is. It goes up 1 over 1, up or over 1. So those are different things you could figure out, but I've just helped us out a little bit in these examples. Since I know the slope of that line is 1 and the y-intercept is 5, I could make an equation for it in slope-intercept form, correct? And I'll tell us when we're going this direction, when we're going from the graph to the inequalities, the best way is going to be by putting things in slope-intercept form. That's going to be the easiest way to do it. So if I made an equation of that graph, it would look like y equals, well, the slope is 1, so I'd have 1x plus 5, or just x plus 5. I could write it like that as well. To make it an inequality, I just need to look like we did at the end of chapter 6. We did some of this. I just need to look at what type of line I have. And in this case, if I look at this line, it is a solid line. And where is the area shaded? Well, it's shaded below the line, correct? So knowing that it's a solid line, I know I'm going to have one of the equals here. And since it's below the line, this is going to be less than. So this is one of the inequalities that's going to work for that system. Y is less than or equal to x plus 5. Now also notice I've got a dashed line right here, and this dashed line, so that it's kind of like one we've dealt with in the previous problem where it's a line that's a horizontal. So I know it's just going to be y. If I looked at just the equation itself, it'd be y equals 2, because here's where y is 0, and we've gone up 2 from the origin, and we're just straight across. So every point along that line would have a y coordinate of 2. It'd just be up 2 from 0. So I know this equation, if this was an equation of this line, it'd be y equals 2. To make it an inequality, I just need to notice that, well, it's a dashed line, so I'm not going to have one of those bars underneath it that tells me it's equal to, so it's going to be either greater than or less than. And by looking at where we're shaded, we notice that we're shaded above the line. Oops, and I wanted the green marker. We're shaded above the line for this one, right? So that means it's going to be greater than. So y is greater than 2. So there's 2 of my inequalities. I actually have one more here. It's kind of tricky to spot, and as you practice these, you'll get better. But there is actually one more, because this little triangle right here should also be shaded if I just had those 2 inequalities. But notice that it actually stops right here and just shades to the right of what is the y-axis. So this area here should be shaded, and if I just had those 2 inequalities, and you can think about it for yourself too, if I just had those 2, then this little area here would also be shaded. But since it's not, I must have some other inequality that's making it just go to the right, and just shaded to the right of the y-axis. And what would that line be? Well, a horizontal line starts with y, and like it is y equals. So a vertical line is just x. And in this case, the y-axis itself is where x is 0. So it'd be like the line y equals 0. Now, there's nowhere to notify me that it's a dashed line, so I'm going to assume it must be a solid line that we're talking about. And in this case, we shaded to the right of it, so all x values that are greater than, so x is greater than or equal to 0, there's our third inequality. So making those three inequalities, that would be what would make up this shaded region. I'm going to do one more example for us, and this one, maybe without the kind of the special cases, the horizontal or vertical lines, but still one we should be able to figure out. So they've given us some shaded region right here, intercased in all these different lines. And if I can figure out the equations for each of these lines, then I can just modify them and make them inequalities, and I should be able to make the system of inequalities that would give us just that shaded region. So first I'm going to start off with, well, this line right here. This one's a dashed line, and it's got a slope, as I've kind of again helped us out a little bit. You could find this information, as we've done that many times before, but you could find this information. You could see that the slope is -1, down 1, over 1, down 1, over, and to find more points. The y-intercept is right here at -4. So again, I've kind of pinpointed that information for us already. But how would I make this equation? Well, I'm going to write slope-intercept form up here first, just as a reminder, because that's what we'll be using. But slope-intercept form would be y equals mx plus b. So if I just plug those things in, I'd have y equals -1x minus 4. Well, now again, just being a system of inequalities, and the fact that we're shaded above the line or below the line, or have a solid or dashed line, I just have to change the equal sign into some inequality. In this case, it's a dashed line, and I'm shaded above. So that tells me it should be a greater than sign. The dashed part tells me it's just greater than, not greater than or equal to. And because we're shaded above, I know it's got to be greater than. This one right here, same idea. I can make an equation for it. Y equals, well, -1x plus 2. But now if I'm looking at this line, we're shaded below it. It's also dashed. Because it's below it, it'll be less than. So I can make an inequality for that one too. Y is less than -x plus 2. And my last one here, this one's going to be my only solid line, but first making the equation. Y equals, well, I should have 2x plus 8 for my slope and my y-intercept plugged in. This one also, notice it's a solid line and shaded below. So again, that tells me if I can make the equation first, then I can just change it to the inequality. It's a solid line and it's shaded below, so y is less than or equal to 2x plus 8. So that's the idea when we're going from a graph to an inequality. If we can find the slope and the y-intercept, slope-intercept form is usually going to be the best helper for us to be able to graph those, or to make the inequalities for that graph.